Welcome to clickmeproject.com. An efficient facial feature extraction technique for face recognition system using local binary patterns. In this work, we present a novel approach to detect the face recognition, which considers both the shape and the texture information to represent the face images. The face area is first divided into small regions from which local binary pattern histograms are extracted and concatenated into a single, spatially enhanced feature histogram efficiently representing the face image. The recognition is performed using a nearest neighbor classifier in the computed feature face space as a dissimilarity measure. Extensive measure experiments clearly show the superiority of the proposed scheme overall considered methods, that is PCA, Bayesian, extra personal classifier, and elastic bounce graph matching, and ferret tests, which include the testing of the robustness of the method against different facial expressions, lighting, and aging of the subject. In addition to its efficiency, the simplicity of the proposed method allows for very fast feature extraction. Our proposed method uses the LPB feature extraction method and the multi-SVM classifier for the recognition purpose. This is the overflow of our project. It consists of test images and training images. Initially, we load the test image, which is to be recognized, and then the input image is pre-processed using the pre-processing block. By using any one of the filtering technique is used to remove the noise from the input image. The input image is loaded and then converted into a grayscale image. In pre-processing, we apply the filtering technique for the input image. Now we apply the median filter to the input image. The median filter is a non-linear digital filtering technique often used to remove noise. Such noise reduction technique is a typical pre-processing step is to remove the results of the data processing. Median filtering is very widely used in digital image processing because under certain conditions it preserves edges while removing noise. Median filter returns the median value of the pixels in a neighborhood is non-linear, is similar to a uniform blurring filter which returns the mean value of the pixel in a neighborhood of a pixel. Unlike a mean value filter, the median tends to preserve step edges. The same procedure is followed for the training images, and after the filtering technique for the both input test images and the training images, we extract the LPB feature. Here we extract the test feature for the input image, and here we extract the training feature for the input training images using the LPB, that is locally binary pattern. In local binary pattern, divide the examined window into cells. For each pixel into a cell, compare the pixel to each of its 8 neighborhoods. Follow the pixels along a circle where the center pixel's value is greater than the neighbor's value, then we replace it by 1, otherwise 0. Compute the histogram over the cell of the frequency of each number occurring. Optionally normalize the histogram, concatenate histogram of all cells. This gives the feature vector for the particular window. Repeat the same procedure for all the windows. After the feature extraction, both the inputs are training features and the test features, and the true label is given input to as a multi-SVM classifier. Multi-SVM classification method is used to recognize the input image. To achieve this, we train the multi-SVM by using 3 parameters, namely true label, training features, and the test feature. By learning, the multi-SVM classifies the input image is authenticated or not. SVM classifier is a machine learning. It's a field of study that gives the computers the ability to learn without being explicitly programmed. Given a training set, we feed into a learning algorithm like SVM, artificial neural network, logistic regression, linear regression, etc. The learning algorithm then outputs a function which for historical reasons is called hypothesis. Basically, the hypothesis job is to take a new input and give out an estimated output or class. The parameters that define the hypothesis are what are learned by using the training set. After the feature set has been computed for each pixel, it will be used by a classifier to decide whether each pixel represents a tumor pixel or normal pixel. The classification stage has 2 components, a training phase and a testing phase. In the training phase, pixel features and their corresponding manual labels represent in the input, and the output is a model that uses the features to predict the corresponding label. The multi-sim gives the output of the person 1 or 2, and as follows. And in performance evaluation, we calculate the performance measures like sensitivity, specificity, and accuracy of the classifier. Simulation results show that our multi-sim classifier outperforms than the other methods. Select main one file and right click on it, and then select run file. A new window is appeared. Select the test image from the test image folder. Select any one of the person from this. After selecting, the input image convert into grayscale image, and we apply the median filter for the input image, and we extract the LPP feature for the test image. The UE table will display the test feature values for the input image. These are the test feature values of the input image, and after that we recognize the person is authenticated or not. This axis shows the correct identified person. The name of the person is Mary. From this, I conclude that face images can be seen as a composition of micro patterns which can be well decided by LPP. We exploited this observation and proposed a simple and efficient representation for face recognition. In our approach, a face image is first divided into several blocks, from which we extract local binary patterns and construct a global feature histogram that represent both the statistical of the facial micro patterns and their spatial location. Then face recognition is performed using the multi-SEM classifier. Our multi-sim classifier accurately identify the person is authentic or not. Thank you.